All right, so we're going to go over direct variation now. Your learning target is I can identify, write, and graph direct variation. So first, a definition of what direct variation is. What direct variation is, it's a special type of linear equation. And it's written in the form y equals kx, where that blank is k, that variable k, is a non-zero constant. So an example of this would then be something like, move the page, something like y equals 3x, or y equals negative 2x. Those would all be different examples. Something that wouldn't work would be like y equals 3x plus 4. That doesn't work, okay? Because we're adding in some constant variable. Direct variation just has the y, some number that's not 0, and then x. So in example 1, we want to tell whether or not each relationship is a direct variation and then explain it, right? So here's how we do this. Essentially, we can tell if direct variation is happening or not if we have the y over the x is the same exact thing for each table, okay? So let's take a look here. We've got our first one, y over x, remember, 6 over 2, which reduces down to 3 over 1, okay? So that's 3 over 1. The fraction between the y and the x is 3 over 1. For this one, we have 12 over 4, which reduces down to 3 over 1. And finally, 18 over 6, which also reduces down to 3 over 1. So because every single one of these reduces down to the exact same ratio there, that it's all three of them are going to be 3 over 1, that means we are dealing with something that is a direct variation. So if you look at this, what this equation then would be is y is equal to 3 times x. That would be the actual equation for this. So we would say yes, and our reasoning, our explanation would be because y over x is equal to 3 over 1 for each one, okay? Now b, if we look at b, we can tell this fraction is going to be a negative 2 over 1. This one is 0 over 3, and finally we've got 4 over 7. Every single one of these are different, and so because they are different, that means that this is not going to be a direct variation, okay? So no, each y over x is different. What we see would actually be happening here is this is more of a y is equal to x minus 3 type of a thing. We see 1 minus 3, 3 minus 3 is 0, 7 minus 3 is 4, okay? And so that doesn't work. That's a linear function, but it is not in direct variation. So example 2 says they want to know the value of y varies directly with x, okay? That's just what we know. And it says y equals 3 when x equals 9, and we want to find y when x equals 21, okay? So we already know that we're dealing with something that has direct variation, okay? So the way that we could do this is we could set up a proportion to kind of figure out how this works, okay? So we know y is equal to 3 when x equals 9. That means we have the fraction 3 over 9. Okay, 3 over 9, just like we did above. Remember, it was y over x. And that should be equal to y when x is 21. And we just want to figure out what is the value of y. Okay? So now we've just got a proportion. You guys remember, when we have a proportion, you can use the golf club rule. One thing I'm going to do real quickly, though, is because we have a fraction that we could reduce on this left side, we could reduce this to 1 over 3. Now, be careful, okay? Because we have this equal sign, we're not multiplying here, we cannot cross-cancel, okay? We cannot cross-cancel. We can only reduce a fraction on one side or the other. And so we've got this reduced, and so we're going to do the golf club rule now. 1 times 21 is 21. 3 times y is 3y. And so divide by 3 on both sides, and we end up getting that y is equal to 7. So when y is 3 and x is 9, y is also 7 when x is 21. All right, example 3 is a word problem. It says a group of people are tubing down a river at an average speed of 2 miles per hour. Write a direct variation equation that gives the number of miles y that the people will float in x hours. Then graph. Okay. So let's. The very first thing that I would do in this kind of a situation is to create a table. Okay. So we've got time in hours, right? And this is our x. Okay. And on the other side we have y, which was miles. Alright, and we know that if we are spending, let's just go ahead and try 4 of these here. 1, 2, 3, and 4. If we are tubing for 1 hour, well, we're going 2 miles per hour, right? That means we will travel 2 miles. If we are going 2 hours, we're going to travel 4 miles. 3 hours will be 6 miles, and 4 hours will be 8 miles. Okay, and so we can see the direct variation here. If we take every y over x, it's 2 over 1, 4 over 2, which reduces to 2 over 1. And so our direct variation, our y over x, is equal to 2 over 1. Every single one of these reduces to 2 over 1. So our equation then is y equals 2x. Y equals 2x. And we can check this, we can see that that will work. So now we just need to graph this, okay? So I'm gonna move this down and I'm gonna make a graph. You guys can make a graph, pause the video and make a graph too, is what I would do. And voila, we have a graph made for us. And so let's go ahead and just graph this stuff from the table here. We know that at 1 hour we travel 2 miles. At 2 hours we're gonna have 4 hours, or 4 miles, sorry. 3 hours is gonna be 6 miles. 4 hours is 8 miles, okay? It's going to look something like that. Obviously, our graph is not necessarily going to be perfect because there's got to be some element of human error, right? And you know how errorful I am. So it's going to look something like this, okay? That's the graph. So when you're given a word problem, that's really all you need to do is just build a table and then you can make a graph off of it after making the equation. All right, thanks.